Hi everyone. Today we'll be discussing DeltaStream's role-based access control, or RBAC for short. DeltaStream is a platform to unify, process, and govern all of your streaming data. And RBAC is a critical feature that enables data governance in DeltaStream. Traditionally, in streaming storage systems such as Kafka, access control is managed through access control lists, or ACLs. Using these lists, if a user needs access to a particular Kafka topic, an access control admin would need to add an entry to the list to give that user access. If the user needed access to another topic, then another entry into the list would need to be added. While it's a simple to understand mechanism, as more and more users need access to more and more topics, the list can very easily grow to an unmanageable size. Then it can be really difficult to know, as the admin, who actually has access to which topics. When access control becomes unmanageable like this, it can become a security risk because a user could accidentally be given access to data they're not authorized to, and it will be harder for admins to notice. Instead of using ACLs, DeltaStream uses RBAC for access control instead, which is easier to use when the number of users and data objects scales. Organizations can also set up roles such that it models their actual team structure. Let's go over a use case using DeltaStream CLI to show off how RBAC works to manage access to your streaming data. For our use case, suppose we have two Confluent Cloud clusters, one for production data and one for staging and development. While DeltaStream supports all kinds of streaming storage systems, for this particular use case, we're using Confluent Cloud's Kafka offering. Using DeltaStream, we can define relations for the topics in these Kafka clusters, then define roles and access privileges to these relations. The goal of our use case is to have separate access to the stage and prod data. If we list our stores, we can already see the stores for our two Kafka clusters. These stores represent the connectivity between DeltaStream and the data storage. To create more stores, we could use the create store command, but for this video, we'll just use our predefined stores. Within each store, we can list the topics. For example, in the prod Kafka store, we can see topics for page views and users. Using the print command, let's print the data in both of these topics to see what they look like. In the stage Kafka store, there is a topic for page views, but not for users. We want to set up our use case such that the organization of data in the streaming catalog matches the roles we want to create. This way, it'll be intuitive which roles have access to which namespace of data. Let's first set up our roles. Creating and managing roles is an admin-level responsibility. There are a certain set of built-in administrative roles in DeltaStream. The user admin role is responsible for creating roles and is the one we'll be using today. As our best practices state, the role hierarchy for roles that are responsible for data objects in the system should be created under the sysadmin. We'll first create an umbrella role for our Kafka data called Kafka Manager. Next, we'll create roles for our stage Kafka and prod Kafka under this Kafka Manager role. Users need to be explicitly granted roles, so we'll grant all of these roles to the current user. In preparation for filling out the streaming catalog, let's grant some permissions to our custom roles. To grant privileges, we need to use the security admin role. The stores that we have were created with the sysadmin role. Now that we have prod and stage specific roles, we want to grant access to these roles to use the stores. We'll first switch over to the sysadmin role. Using the sysadmin role, we'll grant usage to the stores for their corresponding roles. Now we can use our custom roles to start creating databases, schemas, and relations. Let's start with the prod Kafka manager role. Using this role, let's create a database called prod.db and a schema in this database called traffic, since our data is website traffic related. We can set our current database, schema, and store for our CLI session with the use command. Next, let's create our relations that are backed by the page views and users' topics. Page views stream represents the data in the page views topic. As you can see, we are specifying the same fields we saw when we printed the topic earlier. The user's logs changelog is similar to the stream declaration, but changelogs also specify a primary key. In this case, the primary key is user ID. Now we have our prod data all set up. Since we created the database, schema, and relations using the prod Kafka manager role, then only this role and the roles above it will have access to these data objects. Let's now do the same for our stage data. If we now list our databases using the stage Kafka manager role, we should only be able to see the stage DB database and not the prod DB database. Now let's switch to the prod DB role and list our databases there. Now, if we switch to a role that inherits both roles, such as our Kafka manager role, we should see both databases. So, as users get added to this organization, different roles can be assigned to users depending on what kind of data access they require. Let's say the stage team needs access to see the user's data in the prod database. As the Kafka manager with this setup, it's easy to write a query to remove PII from the user's prod data and make that data available to developers on stage. Notice in this query's projection, we are only selecting a few fields that don't leak too much personal information. In particular, we are not selecting the contact info, gender, or interests field. This SQL statement will create a new changelog called users log cleaned in the stage DB database. Behind the scenes, a long-lived continuous query will read from the prod users log changelog, drop a few fields, and write the results to the stage users log cleaned changelog. Writing such a query is only possible from the Kafka manager role in our current setup, because this role and all roles above it have access to both the prod and stage data objects. Since we created this changelog with this Kafka manager role, we need to grant access to the new changelog to the stage Kafka manager also. Going back to the stage Kafka manager role, we can see and inspect this new relation. Let's see the results from our cleaned users log data by writing a select all query. As you can see, the PII fields such as contact info, interests, and gender, which were present in the original user's data, has been excluded from the results set. So users who have access to stage data will only be able to see this cleaned version of the user's data. If we try to describe the original user's log data, we'll get an unauthorized error message. That's it for this video. Now you have a better understanding of how RBAC can be used in DeltaStream to manage data access. As more topics, users, and teams get involved in the data platform, tools like RBAC become necessary for managing access control at scale. If you want to learn more about RBAC or data governance at DeltaStream, there are a few blogs and subject linked in the description below, along with a free trial of DeltaStream.